Hi, welcome to my channel. In the previous videos, we discussed about the MNST dataset, MNST dataset, and training a binary classifier, training a binary classifier, and performance measure, performance measure using cross validation, confusion matrix, confusion matrix, and some of the other performance metrics like precision, recall, F1 score. So here we also find out the accuracy and precision recall, precision recall, trade-off, trade-off, and also we will find out the ROC AUC curve of the AUC curve of the binary classifier. Now, in this video, we are going to discuss about the what is the meaning of multi-class classification and how we are going to find out the performance of the multi-class classification. So now, whereas what is the meaning of multi-class classification? Okay, so first of all, you have to know the what is the meaning of binary classifier. In the binary classifier, first of all, in the MNS dataset, we are having the 70,000 handwritten images are there. Handwritten images between the 0 to 9 handwritten digits. These 70,000 images are divided into two parts. That is 60,000 images for the training purpose, and 10,000 images are used for the testing purpose. Okay. So here the class labels are the 5 is a one type of class label and handwritten 5 is one type of class label, and 0, 1, 2, 3, 4, 6, 7, 8, 9 are other class label. That is this is a 5 class label, and all these are belong other elements are nothing but a not 5 class label. Like that, here the class label is called as a two class label. This is a class 1 and other class is a class 2. So simply this is called as a binary class classification problem. In the previous videos, we discussed about the how to train the binary class classifier. Okay, so binary class classifier distinguishes between the two classes. That is here we are distinguished between the 5 and not 5 classes. Based on these two classes, we constructed we developed a model. Okay, that is called as a binary classifier. Binary classifier. On this binary classifier model, we are going to find out the performance of the all the models like we are find out the confusion matrix. Okay, accuracy, precision, recall, F1 score, precision recall trade-off, and ROC curve and AUC curve on the basis of the binary class classifier. Now, in this video, we are going to see what is the multi-class classification. So, multi-class classifiers, it is also called as a multinomial classifiers. Can distinguish between the two or more than the two classes. That means more than two classes. Like here, class 1, class 1, class 2, class 2, class 3, like that. Class 3, like that. We are having more than two classes. In the previous binary class classifier, it contains only 5 and not 5. Okay, here it may be each and every class. It may be 0 is a one class, 1 is a one class, 2 is a class, 3 is a one class, 4 is a one class, and each and every element is becoming one class. That is simply called as a multi-class classification problem. Okay, now some algorithms like stochastic gradient classifier, random forest classifiers, and naive-based classifiers are capable of handling the multi-class classification problems. Okay, mainly stochastic gradient classifier, random forest classifiers, and naive-based classifiers are used for to handle the multiple classes. Okay, And whereas logistic regression support vector machines are strictly binary classifiers. Both these are strictly for the binary classifiers. Now there are different various strategies are required to perform the multi-class classification with the help of multiple binary classifiers. With the help of multiple binary classifiers, we can perform the multi-class classification problem. Okay, now one way to create a system that can classify the given digits into 10 classes, like we are having the digits are 0 1 2 3 4 5 6 7 8 9. These are the different class labels are there. Now whenever you are giving the new one image, we are giving the one image like given 5 or okay, so this 5 must be belonging to a one class label, that is the class label 5. Okay, like that there are in order to find out the class label given image, okay, there are different approaches are there. Okay, for that, to train the 10 binary classifiers first of all, and for each digit, one for each digit, like a 0 detector and 1 detector and 2 detector and so on. For each and everything we have to find out the binary classifiers. Okay, then we want to classify an image. We get the decision score from the each class label, each classifier for that image. Okay, then you select the class whose classifier outputs the highest score. Then that become the class label of the corresponding given input image. Okay, first of all you have to find out the decision score of the each and every image. Then according to the score, okay, then we have to give the class label for that one. So this is called as a one versus rest strategy. This strategy is called as a one versus rest strategy. So this is also called as a one versus all strategy. One versus all strategy. Okay, one versus rest or one versus all strategy. So another strategy is to train a binary classifier for the pair of digits. Okay, so one to distinguish between the zeros and ones, and another way is to distinguish between the zeros and twos, between the zeros and twos, and one and twos. Like that, we are going to find out the distinction between the each and every pair of elements. So this strategy is called as a one versus one strategy. One versus one strategy. Okay, so if there are n classes are there, in our example there are 10 digits are there, 0 1 2 3 4 5 6 7 8 9. There are n number of elements are there. So here the n equal to 10 digits. So now we need to train the n minus 1 by 2 classifiers. That means 10 into n minus 1 means 9 by into by 2, that is equal to 45 times. Okay, so here for the m minus problem, so here the problem is m minus data set. This means we are going to find the 45 binary classifiers in this example. Okay, now when you want to classify an image, you have to run the image through the 45 classifiers and see which class wins the most views. Then that becomes your class labels. So the main advantage of one versus one is that each classifier only needs to be trained on the part of the training set for the two classes that must be distinguished. So some algorithms like support vector machines classify the scale poorly with the help of size of the training set. Okay, for these algorithms, one versus one is the preferred because it is faster to train the many classifiers on the small training sets than to train the few classifiers on the large training sets. Because of that one, we are going to use the one versus one classifiers. So for the most binary classifier algorithms, one versus rest is preferred. Okay, scikit-learn detects the when you try to use a binary class classification algorithm for the multi-class classification task. That means you are going to use that perform the multi-class classification. You are going to use the binary class classification algorithm. It automatically runs a one versus rest or one versus one algorithm strategy depending on the algorithm. So we are going to use the support vector machine classifier using the sklearn.svc svm.svc class Okay, from the sklearn.svm, we are going to import the support vector classifier, that means SVC. From our model is svm underscore classification, that is equal to SVC classification. So svm and classification dot fit function, that we are here. We are going to, this is your model, and we are going to find train the model with the help of extern and y train. So svm underscore classification that predict some digit. We are going to give some digit. Okay, if the digit is 5, the data type also unit 5, unit 8. Okay, the type of the data is unit 8. Okay. So here this code trains the SVM on the training set using the original target class labels from 0 to 9. That is our training y train contains 0 0 y train. The class label contains 0 1 2 3 4 5 6 7 8 and 9. These are the some of the class labels. Okay, this is called the y train. Okay. Now, instead of the 5 versus the rest target classes y underscore 10 underscore 5. So then it makes a predictions. Okay. So sklearn usually uses the 1 versus 1 strategy. 1 versus 1 strategy. It trained 45 binary. It trained 45 binary classifiers to get the decision scores for the each and image, and select the class that won the most duels. Okay. So if you call the decision functions method, okay, you will see that it runs the 10 scores, 10 scores for instance, 10 scores for the instance, that one score for class. Okay, some digit scores equal to some our model is support vector machine classifier. We are finding the decision underscore function for the given digit image, given digit. So now we are going to display the scores of it for that corresponding digit. Now it displays them all the scores of the corresponding digit. Okay, with respect to all the 10 classes. So 2.992, 0.27, 3.9, okay, 0.9 and 5.9, okay, 9.5, 1.9, like that we are having the things. So these are the scores for the handwritten digit 0, handwritten digit 1, handwritten digit 2, handwritten digit 3, for the 4, okay, for the 4, and this is for the 5, okay, and this is for the 6 and the 7, 8, okay, and this is for the 9. Here which is having the highest score, that is 9.5. So that is class belongs to the handwritten digit 5. Okay, like it we are going to find out the class decision function for the based on the decision scores. Now the highest score is indeed the one of the corresponding class to the 5. Okay, np.org max, we are going to find out the maximum score among the given hand scores. Okay, based on the some digits underscore 5. So the output is 5. Okay, so some classes support vector class space, the classes are the given set of the data set contains the classes are belonging to 0 1 2 3 4 5 6 7 8 and 9. So the here the maximum class is 5. So the output is the corresponding class level is 5. Okay, when a classifier is trained, it stores the list of target classes in its classes attribute. It in its classes attribute ordered by the value. Okay, in this case the index of each class in the classes underscore array conveniently matches the class itself. That means the class at the index 5 happens to be the class label 5. Okay, now but in generally you want to be so lucky. Okay, so if you want to force the scikit-learn to use 1 versus rest or 1 versus 1, okay, you can use them 1 versus 1 classifier or 1 versus rest classifier classes. Okay, so simply create an instance and pass the classifier to its constructors. Okay, so for example in this code it creates a multi-class classifier using the 1 versus rest strategy based on the support vector classifier. So from the sklearn multiclass, sklearn.multiclass, we are importing the 1 versus rest classifier. That means 1 versus rest classifier equal to 1 versus rest classifier. Based on the, we are going to create the support vector classifier, and over the 1 versus classifier dot refitting the function. That means you're going to train the model with the help of x train and y train model, and we're going to predict the corresponding output value. Okay, so one versus dot underscore classification dot predict the sum underscore digit. So we're going to find out the class level for this one. The corresponding index value is 5, and the data type of the corresponding class label is unit. Okay, unit 8. So the length of the one versus classifier estimators is 10. The total number of elements are in the thing is 10. So we are going to find out the how to train the model. Okay, so in the stochastic gradient classifier or random forest classifier is a very easy to train the model. So here we are going to use the stochastic gradient classifier dot fit. We are going to use the train the model with the help of stochastic gradient classifier. Further, we are providing the x underscore train value and y underscore train value, and stochastic gradient classifier and dot predict the some output value for the given input image. Okay, so here it displays the output as the index value is 5 and the data type equal to unit 12. Okay. So this times the SK learner did not have to run the 1 versus test or 1 versus 1 because of the stochastic gradient classifier can directly classify the instances into multiple classes automatically. So the decision function method now returns the one value for classes. Okay, automatically run the one value for the each and every class. So here we are going to use the score that assigned by the stochastic gradient classifier. Okay, so the scores of the given the decision score for the each and every digit is given by the stochastic classifier is so here stochastic gradient classifier the decision function and for the given input image. So here these are the sum of the all the decision scores for the digit 0, digit 1, digit 2, okay, digit 3, and digit 4, digit 5, digit 6, digit 7, digit 8, and digit 9. And among all the scores, the 5 digit having the highest score, that is 2412.53175. Okay, now you can see that the classifier is fairly confident about its predictions. Almost all the scores are largely negative, while the classifier has scored 2412.5. Okay, the model has the slight doubt regarding the class 3 which gets the score 573.5. Okay, so the class is all the things are having the negative values only. Okay, all the remaining classes, but only two classes are having the positive score, that is class level 5 and class level 3. So here the class level 5 and class level contains here 573.252, here 2412. So here in these two classes the class level 5 has the highest score. So that's why we are going to assign the class level as a 5 for the given digit image. Okay. Now this is about the stochastic gradient classifier. Now here we are going to use the cross underscore val underscore score function to evaluate the stochastic gradient classifier accuracy. Okay, so cross underscore val underscore score, we are going to provide for the parameters. One the model is stochastic gradient classifier, and the training data is x underscore train data and y underscore train data and cross validation equal to 3 and scoring equal to based on the accuracy. Okay, now the array displays it contains three parts of the data. Okay, three parts. Okay, three values are there: 0.84, 0.87, 0.86. Okay, in all the cases 80% of all the good performance, 8% of the results are given all at false. Okay, that means here the data set is divided into three parts, three folds. So that is k fold 1, k equal to 1, k equal to 2, okay, k equal to 3. So in all the three cases, at one time we are going to use the k equal 1 and 2 as a training purpose, and 3 equal to k equal to 3 as a testing, and K 2 and 3 are using for the training, and 1 is for the testing, and 1 and 3 are going for the training, and 2 is for the testing. Like and all the cases, 84% give the accuracy of the each and every folds. Okay. Now you can random, if you use it to use as a random classifier, you will get the 100% 10% accuracy. Okay, so this is not such a bad score. So but you can still do much better. Simply scaling the input increases accuracy about the 89%. 89%. Okay, from the sklearn dot pre-processing import the standard scalar equal to standard scalar. Okay, our model, we are going to perform the standardization of our data based on the standard scale. We are going to normalize data, and on the normalized data set we are going to find out the our model. Okay, so here we are using the standard scalar as a pre-processing step that is assigned to scalar. Now the training data, okay, x underscore training scale converted into scale form, that is scalar dot fit underscore transform. So here for that we are going to provide the x underscore train as type np dot float of 64. After that we are going to perform the class values score based on the stochastic gradient classifier, and on the scaled trained data set, we are going to find out the things more. So while for that we are going to go training data x underscore train value and y underscore train value, class value is equal to 3, and scoring equal to accuracy. Okay, now after that we are going to find out the corresponding scores. Okay, 0.89, 0.89 and 0.90. So in the previous we are having the without scaling we are getting the values in the form of a 0.84%, but here we are getting the values more than 5% above. Okay, that is 0.89, 0.989 and 0.9 in all the three folds. Okay, so in like that we are going to find out the one word multi-class classification problem. Okay, in the next video we are going to use the how to find out the error analysis of the given model. Okay, thank you for watching our video.